Today I'm going to talk to you about how words are represented in machine learning. If you're trying to solve a problem like text classification, for instance deciding if an email is spam or not, you start with a bunch of strings as training data. But before you can do any machine learning, you need to convert those strings into something the machine learning algorithm actually understands: vectors of numbers. There are two main ways words are represented in the practice of machine learning today. One is called the bag of words model, and the other is called embedding. The simplest bag of words approach is called a vocabulary list. You take all the words that appear in your training data and you make each of them a feature. This means for each document, you mark down the number of times that word appears in its feature column. You might notice that a lot of these columns are going to be 0, and as the dataset grows, you could have up to 10 or 20,000 of these feature columns. A lot of them being 0 means that the features are very sparse, and machine learning models really don't like sparse features. But there's a way we can solve this problem. We can use something called the hashing trick. To use the hashing trick, you define a number of buckets beforehand, let's say 5, and then for each word in each document, the hash of that word modulo the number of buckets is the index of the bucket you increment. This means our features are always very dense, and they're always a fixed size, and machine learning models love that. But one problem with using bag of words models is that it takes every word out of context. You can fix this by using embedding, the other way of representing words in machine learning. There are two ways of doing embedding. One is called the skipgram model, and one is called continuous bag of words. In each one, you train a neural network to pre-process your data. In the skipgram model, you train a neural network to predict the surrounding words given one word. In the continuous bag of words model is the inverse, where you predict a word from the surrounding words. The skipgram model is more computationally intensive because it has more output classes, but it's usually more accurate. Word embedding was popularized by an approach called Wordevec, developed at Google in 2013. It generates these dense feature vectors that have geometric relationships that are really cool. For instance, men and women relate geometrically to king and queen. You can do really cool things with it. For instance, like Rome minus Italy plus China equals Beijing. And that's all I have for you now. Thank you for watching.